Symmetry. A figure has symmetry if one half of the figure is the mirror image of the other half. A line of symmetry is a line that can divide a figure into halves that are mirror images of one another. So if we look at this leaf, we have a line of symmetry right down the middle. And if we were to fold the leaf directly on that line, it would be the same on both sides. So that's what symmetry is, especially regarding a line. Line symmetry is a reflection across a line that divides a figure into two congruent halves. The two halves reflect onto each other. One is a mirror image of one another. Here are 4 examples of line symmetry that are shown. Now, these are not the only lines of symmetry that can be drawn. More are possible in certain shapes, such as a rectangle, a star, and an equilateral triangle. So more can exist. Draw lines of symmetry where applicable. Well, let's start with the letter A. The letter A is symmetric about the middle of it. So if we were to draw a line straight down and fold the left side, it would correspond directly with what's on the right side. With a B, this has line symmetry in a horizontal manner. And if we were to fold it horizontally over that horizontal line, you can see that the top section will line up with the bottom section. Very similar with the letter C. It has line symmetry directly through the middle, splitting it into top and bottom halves. D, the letter D also has that line of symmetry, splitting it into a top half and bottom half. Same with the letter E. You can fold it along the middle line and the top and bottom correspond. The letter F has no line of symmetry. So this triangle appears to be equilateral. And when that happens, you can actually draw 3 lines of symmetry over the shape. And usually with regular polygons, such as an equilateral triangle, the number of sides represent the number of lines of symmetry. Since an equilateral triangle has 3 sides, there are 3 lines of symmetry that we drew. Next, we have a regular pentagon. As stated before, when you have regular shapes, the number of lines of symmetry correspond to the number of sides that the shape has. So far I've done 3, and then we can do 4, and then the last one will be through this vertex with 5. So indeed we have 5 lines of symmetry there, 3 here, 1, 1, 1, 1, and 1 that we had drawn before. Okay, this heart, if it was just a regular heart, it would have a line of symmetry straight down the middle. However, because of this pattern with the extra big pieces, one extra big piece is higher on the left when compared to the right. So therefore, this one has no line of symmetry. These shapes have more than one line of symmetry. Draw all of them that exist. Okay, so this is a square, and a square has straight down the middle. Similarly, I could fold it in half horizontally that way, and we can also go diagonally. And as we found with the equilateral triangle before, which had 3 sides and 3 lines of symmetry, this one also has 1, 2, 3, 4 lines of symmetry. The next one that we have is a regular hexagon. And similarly, we are going to have 6 lines of symmetry. Here's the first one. Second one that you can draw is through the corner. Third one is in the middle of this side. Fourth one should be a horizontal. Let me fix this part. There we go. It's going to go right down the middle and go horizontally. That's 4. 5 goes through here, and 6 goes through this last set of vertices. So this one again has 6 lines of symmetry. For the next one, we have an equilateral triangle, and we have 1 line of symmetry, 2 lines of symmetry, and 3 lines of symmetry. And now with this regular pentagon, we have 1 line of symmetry there. There's the second one. Here's the third one. Then the fourth one. And the fifth one. So there are 5 lines of symmetry in this regular pentagon. And the last figure that we have here is a rectangle. A rectangle can be folded horizontally as well as vertically to get the same shape on both sides. And notice that because this is not a square, we can only draw 2 lines of symmetry in this rectangle. We cannot draw them about the diagonals. If that ended up happening, you would end up getting a rectangle still, but it would be, the longer sides would be vertical instead of horizontal if you were to reflect them about diagonal lines. So again, therefore, the rectangle only has 2 lines of symmetry.